Hi folks, and welcome to another online maths tutorial from CD Masterworks Limited. So we'll be looking at a wee topic from the expressions and functions unit today. We'll be focusing on what's called the wave function. So we're going to just focus on skills 1 and 2 today. So we're going to look at the wave function for first quadrant angles, and then we'll extend that a wee bit with second, third and fourth quadrant angles as well. So our bronze skill will be calculating the wave function for first quadrant angles. So our typical wave function question will be as follows. Express root 3 cos x minus sin x in the form k cos x plus a, where k is greater than 0 and the angle A lies between 0 and 360. So normally when you see an expression with cos x and sin x in it, that's usually a hint that it's going to be the wave function. So we have our expression k cos x plus a, and what we're going to do first of all is, using the formula sheet, we're going to expand this. So in the formula sheet there's expansions for sin and cos with a plus or minus b. So we're going to use those expansions, and that gives us k cos x cos a minus k sin x sin a. And we need to remember to put those k's in, otherwise we've not expanded it correctly. Once we do that, we're going to write down the values of k sin a and k cos a. So if we focus on k sin a first of all, we're going to look for it in our expansion. So k sin a is in the second bit of the expansion, and we highlight or underline everything that's not the k sin a. So in this particular case we're going to underline, or in this case colour, sin x, and what we do is we look for the corresponding sin x in the original expression. So k sin a is going to equal 1, because as you can see the two negative signs cancel each other out. So we repeat the process for k cos a. So we're going to look for k cos a, it's in the first bit of the expansion, and in this particular instance we're going to colour in cos x, and you'll probably underline that. So k cos a corresponds to root 3. So once we've found k sin a and k cos a, what we do then is we find tan a. So tan a, using the nat 5 trig identity tan x equals sin x over cos x, is going to be sin a over cos a, and that's going to be 1 over root 3. So to calculate angle a, if we know what tan a is, all we have to do is inverse tan 1 over root 3, as all our terms are positive, which therefore means it's going to be in quadrant 1. So the inverse tan of 1 over root 3 is an exact value, it's 30 degrees. And all that's left for us to do is find the value of k. And we calculate k by square rooting the two numbers squared and added together. So 1 squared is 1, root 3 squared is 3, 1 plus 3 is 4, so k is going to be 2. And then we just write down our final answer. So root 3 cos x minus sin x in the form k cos x plus a will be 2 cos x plus 30 degrees. Okay, so here's a few for you to try on your own, and if you're working on these at home, pause the video now. Okay, you've unpaused the video, let's go over some answers. So number 1 is root 29 cos x plus 21.8 degrees. Number 2 is root 2 sin x plus 45 degrees. Number 3 is 2 cos x minus 60 degrees. Number 4 is root 17 sin x minus 14.0 degrees. Number 5, root 74 cos x plus 35.5 degrees. And number 6, root 13 cos x minus 33.7 degrees. And obviously you're not going to be penalised for rounding there. Okay, moving on to section 2, the Selva Scale, where we're going to look at second, third and fourth quadrant angles. So a very similar question, 3 cos x minus 4 sin x in the form k sin x plus a. So key steps are still on the board. Using the formula sheet we're going to expand this, so it's going to give us k sin x cos a plus k cos x sin a. And again you need to remember to include those k's in the expansion. So same as before, k sin a and k cos a next. So we look for k sin a. K sin a is going to be in the second bit of the expansion. This time we're underlining cos x, and that's going to correspond to 3. And then we look for k cos a, which is the first bit of the expansion, so we colour in the sin x, and as you can see, because we've got a positive term and a negative term, means that k cos a is going to be equal to negative 4. So that's slightly different this time. So again we're looking for tan a, and it's going to be sin over cos, so it's 3 over minus 4, so it's going to be minus 3/4. And then we now need to look at calculating angle a, but the problem is that tan's negative, so we need to think about what quadrant our solution is going to be in. So we draw a cast diagram. We've got our A, our S, our T and our C. So at least one of the angles are negative, therefore it cannot be in all. Can't be in cos because cos is negative, can't be in tan because tan's negative. It's in the sine quadrant, and that's because that's the only one that's positive. It's positive 3. So I had to calculate A. We pretend 3/4 is positive for a second, so we inverse tan 3/4, and then we do 180 take away our answer, because that's how we calculate a quadrant 2 angle. So we inverse tan 3/4, do 180 take away answer, and that gives us 143.1 degrees. And then we find k as before by squaring 3 and -4 and adding them together and square rooting them. So that's going to be square root of 9 plus 16, which is the square root of 25, which comes out as 5. And all that's left for us to do is write our final answer. So that's going to be 5 sin x plus 143.1 degrees. So here's 6 for you to try, and if you're working on them at home, please pause the video now. Okay, pause the video. Our last set of answers for today are root 13 cos x plus 326.3, root 2 sin x minus 315 degrees, 2 cos x plus 300 degrees. Number 4, root 26 sin x minus 348.7 degrees, root 97 cos of x minus 156.0 degrees, and number 6, root 58 cos x plus 203.2 degrees. And that concludes our online tutorial for the wave function. Hope you found that useful, and stay tuned for the next one. Okay, bye for now.